Let's now talk about some of the opportunities being brought to life through robotics, right here at QUT. The future of food security for the global population and its sustainability depends a great deal on innovation in the agricultural sector. Robotics and autonomous systems may soon play a key role in assisting humans in managing crops and livestock and increasing profitability and sustainability. Tristan Perez is a professor in robotics and autonomous systems at QUT. His main research interests are in the areas of mechatronics, decision-making under uncertainty, and robot-robust autonomy. Tristan leads QUT's activities in agricultural robotics, where he seeks to develop new robots, mathematical models, and computer tools to assist farmers in making good management decisions. He is also working on bio-inspired robot guidance and motion control, where he seeks to translate behaviours observed in birds and bees into behaviours for robots. So you're an expert in the birds and the bees, Tristan, yeah. Tristan was born in Argentina, where he studied electrical engineering. He came to Australia to do his doctoral degree in applied mathematics and has worked in problems related to ships and ocean structures, mining, econometrics, unmanned aircraft, underwater vehicles, and agriculture. His work has taken him to live in the UK, Denmark, Norway, and Spain, and now you're in Brisbane. Most of his research has been focused on solving problems for industry in the real world, so please welcome Professor Tristan Perez.
All right, thank you very much, and thank you very much for the opportunity to talk to you about some of the research and the activities we are doing at QUT. As you have seen, robotics and autonomous systems are transforming some industries, such as mining, medicine, even law in some areas. And we're starting to see a transition in these areas in agriculture as well. And what triggers that is the issue of food security, which is starting to crawl into the agenda of most of the OECD governments. We have a steep trend in increasing population. There are developing economies who have demands for proteins and changes in diets and changes in the behavior. And this is putting a lot of stress in the production, the amount of food that we will have to produce in order to satisfy the demand from future populations. At the same time, the amount of land that we have allocated for agriculture has almost peaked worldwide. And there is a steep competition in terms of spaces for living and other areas. And on top of that, something that really affects the industry of food production, especially in the farming part, is climate change. Things are changing, and we don't know how they will be evolving. So this is putting quite a lot of stress and needs of innovation. Now, if you look at Australia in particular, agriculture is a very important industry. 3% of our GDP is due to agricultural production, and this is only at the farm gate. So if you start incorporating as well what happens from the farm gate to the plate, so all the value-added change, then that figure of GDP percentage changes to 12%. About 60% of what we produce in agriculture is exported, and about 33% of people in Australia is either directly or indirectly supported by agriculture. We're a very small country, and therefore, in order for our industry in agriculture to survive, we depend a great deal on exports. And here is where the markets are playing a little bit against us in terms of how big our industry is and how competitive we are. So we're not able to provide agricultural commodities at the lowest price that we used to do about 20 or 30 years ago. So innovation is running very high. And this is where robots could play in the future a significant role, because we need to increase productivity, which means farmers need to do more, and the farming industry and the agricultural industry, we need to be able to do more with less. So let's talk a little bit about robotics in agriculture and what's happening. This is not something we envisaged, but I thought it was a nice picture. there are different things that robots can do in agriculture, and some of these things are related to robot enabling sensing. As I said, agriculture is mostly about management and making good decisions, whether it's business decisions or how to manage crops or animals, animal health and quality. So robot enabling sensing is something that is quite important. Robots will be collecting large amounts of data, as we saw today, big data, data analytics, and making sense of data is very important. Data per se is not useful. Data is not information. We need to unpack the information that is in the data, and this is something that is creating at the moment lots of problems for some of the farmers and the growers. And then it's also robot enabling acting. The robots that are collecting the data can also be used to implement certain actions on the crop. Now, in order for this technology to come into life, there are not only aspects of technology that we need to develop a little bit further, but there are also other aspects which we call enabling factors. And at QUT we are working in those areas. Some of them are economics factors and business, some of them are related to regulations and certification, some of them are social and socio-economic aspects of it. And all this needs to be brought up in order for this technology to take up. So I'm going to give you an example. So the picture that you see at the top there, that's the AgBot 2, short for Agricultural Robot. Is a platform that we are developing at QUT with support from the Queensland Government. This is a robot that is designed for management of crops, in particular dealing with weeds and also the management of nutrients in soils. So weeds is a significant problem for our farming industry. Australia spends $1.6 billion a year in trying to controlling the weeds, and we do that mostly with chemicals. And nature is developing now weeds that are becoming resistant. So the number of species that are proliferating, which are resistant to chemicals, is increasing very much. So the idea is to replace the current operations that we do in weed management with a single machine, like a single tractor or a single weed sprayer, by a number of multiple robots collaborating. So what we're able to do by doing this is slow the speed of the operation. So by increasing the number of robots, the time of the operation remains the same, but the speed of the operation gets reduced. And by getting reduced, we can enable new, novel ways of dealing with weeds. So we're using computer vision in order to not only detect the weeds, but also classify and identify. And this can give us information for the robot to make autonomous decisions as to treat the weeds, whether it's with a chemical agent or thermally or mechanically. Also, if environmental conditions deteriorate, the robots can make a decision of, for example, suppress the treatment of the weeds with chemical agents, and that can contribute to enhancing the protection to the environment and avoid situations where, for example, drift is a big issue for herbicides and pesticides, which ends up in our waterways and then, for example, in a barrier reef. So how does this work? Well, given the geometry of a particular field, a paddock, there's a computer algorithm that solves an optimization problem, and then robots get assigned to the paddock. And if one of the robots has a mishap or malfunction, then the other robots take up the work. Yeah? So that's how they operate. And there's also charging stations, so the robot operate autonomously. They can operate day and night, and therefore have a better way of managing some of the weeds. Now, robots. There are a lot of things that can enable us to do in agriculture, but we believe are part of a much bigger picture. So if we look at what we do in agriculture today, what the farmers are doing is they're sensing. They're collecting data. They're analyzing the data to extract information, use that information for making decisions about management, decisions about business. They would like to make the crops and the business resilient. They would like it's a multi-objective optimization problem. They would like to maximize yield, minimize volatility in yield, maximize quality, minimize volatility in quality, and at the same time do more with less, which means have a better use of their inputs. The crops get affected by interactions with environment, as I said, weather, but also the business gets affected by interactions with other markets. So the idea of sensing, thinking, and acting on the crop regularly, it means that you're able to react to these changes and therefore make your system more robust. So how do we envisage this picture changing into the future? Well, the three activities will remain the same, except that we envisage that now we're going to have much more sensing, especially intelligent sensing, deployed sensor networks, unmanned aircraft, all that combined with the current methods that we're using today, and the robots will play a big part in collecting the data that we can use. Then, as some economists say, we are now entering what we call the second machine age. During the first machine age, we increased our mechanical power with machines. Now we're trying to increase our ability to make decisions with machines. So the idea is how do we harness all the data and extract the information in order to assist the humans to make the right decisions. And then the robots as well would help in acting on the crop. How do we implement the actions that we decide to do that? Now this picture that I have shown you covers only one part of our agricultural business. So we have the farms, but on the other side we have the value-added chain. And these aspects get all of our agricultural ecosystem get affected by markets, by policy, and also by weather events. So therefore, I show you that there was this little loop about sensing, controlling, or thinking, and then acting. However, if we move to the value-added chain, we also have something very similar. There is sensing, so we're trying to have sense of how the food, or how the produce is transformed into food in order to optimize traceability and quality, and also make the system robust to, again, emerging markets. And in order to enable that, we need to develop a digital infrastructure. And again, there is a little loop about sensing how technology is evolving. How do we react to this technology to make sure that in 10 or 15 year times, we will have the technology that is necessary to continue the optimization and what we're trying to achieve with our industry. So we believe that this is part of the larger picture. Now, the last of my slides is about the future of the workforce. We envisage significant changes in the way we are conducting operations in agriculture. We don't see people coming out of the loop at all, but we can see people being enhanced and assisted by some of these technologies. We are already starting to see transitions into highly skilled labor. For example, one farmer in North Queensland, for the first time, he told me he has now employed an aerospace engineer to help in developing new type of machinery to do particular operations. Some of the farmers are suffering significantly from labor. They have a casual workforce and they cannot train them properly, and therefore sometimes they suffer significantly from the losses of the crops not being picked properly. So I think I'll leave it here, and thank you very much. It's been a pleasure talking to you today.